Alright guys, welcome to our Unit 5 study guide for the test. Let's begin here. I'm going to be going through the even problems, and the odd problems are left for you to practice with if you want to, with their answers included at the end of the study guide. Alright, so without any further ado, let's begin. So the first thing I want to start off with here on number 2 is just simplifying a square root. The first thing we do to simplify a square root is we're going to break it apart. So I'm going to separate the number from the letter. Next, we have 80 is 10 times 8. 10 is 5 times 2. 8 is 4 times 2. And 4 can be broken down again into 2 times 2. Now, what I'm left with here at the end of every branch are prime numbers. You just kind of keep breaking it down till you get to all the primes. We're not going to include these ones because these got split up, right, into other numbers. But we keep the ones that are at the ends of the tree branches. And so we have here 1 5, 4 2s, and an x. And what square roots do for us is square roots say, do you have a pair? If the answer is yes, you're going to write that number outside the square root, and then you're going to get rid of the pair on the inside. Same thing here. I've got another pair, so I'm going to write that outside the square root, and then I'm going to get rid of the pair. Whatever's left on the inside, you multiply those together, so 5 times x is 5x. And whatever's together on the outside, you multiply those together also. So you get 4. And there's our final answer there for simplifying a square root. So we have another one here, but before we begin, we notice that there's a negative under the square root, and that makes what's known as an imaginary number. So we cross off the negative and we put an I in the front to begin with. But after that, the rest of it is the same as the last problem. So we start by splitting up the number from the variable. Now the variable is x to the third, so that means I have 3 x's being multiplied together. 72 can be found by doing 9 times 8. 8 is 4 times 2. 9 is 3 times 3. And then finally 4 can be broken apart one more time to make 2 and 2. So here are the ends of my branches. The rest of these numbers we don't include because they got split up. And we've got all of our branches there. So now we're going to have an I on the outside. And on the inside we're going to have 3 2s, 2 3s, and 3 x's. So for every pair, we could write that number on the outside and then cross off the pair. And I don't want to forget my I, that's still there. So on the inside I've got a 2 and an x left inside, so we'll just multiply those together. On the outside I've got x times 3 times 2 times I, which is going to be 6xi. And there's my final answer. Next, we're going to talk about multiplying with square roots. So once again, if you see any imaginary numbers in there, a negative inside the square root, we're going to cross that off. We're going to put an I there first. The next thing we're going to do is we're going to put together the numbers outside the square root and the numbers inside. Now, this one has no numbers outside, but you could think of it as a 1 if that's helpful. So the numbers that are outside the square root are 1 and 4i, so I'm going to put those together on the outside. And on the inside, we're going to put the inside numbers together, so 6k and 3k squared. Okay. Now as for the inside, we're going to be splitting all that up as well. So 6 is 2 times 3. K stays that way. Then we have a 3, that doesn't break up, but k squared is k times k. So I've got a 2, I've got 2 3s, and 3 k's. And now we're ready to start bringing out stuff. So I've got a pair of 3's, so I can take a 3 out. I've got a pair of k's, so I could take a k out. On the inside, I have a 2 and a k left, so that's just going to be 2k. Multiplying all this stuff together on the outside, we end up with 12ki, and on the inside, 2k. And there's our final answer there. Another problem is pretty similar, but we'll see a little something different come out in the process here. So first of all, I'm going to take out an I on both of these. Then I'm going to put the outside pieces together. And then I'm going to put the inside pieces together. Next, I'm going to break apart the inside pieces. So we have 5, 3 p's, 4 is 2 times 2, and p to the third is, 3 p's. So on the inside, I have a 5, I've got 2 2's, and 6 p's. All right, and for every pair, we could take one out. So let's do that. I've got to, let me put these ones in there real quick before I forget. So we've got a pair of 2's, so I could take out a 2. Got a pair of p's, another pair of p's, and another pair of p's. And all that's left on the inside is a 5. So let's put together the stuff on the outside. I've got 3 p's times 2 times 2 times 2 i's. So that's going to, the 2 2's make 4, the 3 p's make p cubed, and the 2 i's make I squared. And on the inside we have a 5. Now here's where the little difference comes in. When you have an I squared, that becomes a -1, a real number. And then when you multiply it, all that's going to do is make the front negative. So you really don't even have to show this middle step. What I would do is I would just cross off the I squared and put a negative in the front. All right, let's move on to number 10. Now, when it comes to square roots in fractions, we don't like having square roots on the bottom, and we want to get that square root out of there. That's a process called rationalizing. The way that we get the square root out of a bottom is we multiply the square root by itself, which you're allowed to do so long as you also multiply the top by the same thing. The top is going to be 6 square root of 7. And on the bottom, if you multiply square root of 7 times square root of 7, you get just normal 7. And now we no longer have a square root in the denominator, and that's how we prefer it. Okay. Number 12 is a similar problem. I don't like the square root on the bottom, so I'm going to multiply the top and the bottom by the square root of 2. So now the bottom is just going to be normal 2. On the top, though, it's a little different than number 10, because this time we have 2 square roots being multiplied together, in which case you actually can multiply those numbers together now and get an actual 14. This is the same kind of problem. It just doesn't look the same. I is a square root. It's a square root of a -1. And so we don't like having the I in the bottom, so we solve this issue the same way we did the last two. You multiply it by itself on the top and bottom. So the top is going to be 7i. Now the bottom is 3i squared. And we've talked about how an I squared basically just makes a -1. So the final answer will be 7i over -3. So what we are doing here on number 16 is we are adding two complex numbers. A complex number is a number where you have a real number and an imaginary number either being added or subtracted together. So I've got two complex numbers being added here, And the way you do that is just by combining like terms, basically. I'm going to add the two real numbers together, and I'm going to add the two imaginary numbers together. Now, in that case, they just cancel each other out because they're exact opposites. So my answer there would be -3. On this one, it's pretty similar, but instead of adding, we're subtracting. When it comes to subtraction, we have to do a little extra step in the beginning. You're going to distribute the negative first, which will change these signs into opposites. So instead of -8, it'll be +8. And instead of -2i, it's going to be +2i. And then from there, we can combine our like terms. So -7 and +8 makes 1. 8 and 2 makes 10i. And so there's our final answer. Three plus 6i squared. So in this case, we're squaring a complex number. And that means you're multiplying the complex number by itself. Now I'm going to do this in two ways. The first way I'm going to do this is with a shortcut I taught you guys a couple weeks ago. Anytime you multiply a binomial by itself, you just do first times first, last times last, middle times middle, and then double that number. That's a shortcut we talked about a while ago. Next, you would do the I squared. The I squared is going to make that a -36. So now I've got 9 plus 36i minus 36. We can then combine the real numbers together and get a total of -28. I think it might actually be 27 plus 36i. Now that's the shortcut method. The other way, which is more closely related to what we learned in class, is to use the box method. So I will do that also, but you're going to get the same answer either way. I want to show you the box method because the box method always works. The shortcut only works when the two numbers are exactly the same. The I squared, once again, we know becomes negative. And then what we're going to do is we're going to combine this diagonal. And then we're going to combine this diagonal. And we have our final answer. So it seems like the shortcut really isn't that much shorter, honestly, for these problems. So probably the box method is a good choice. All right, so we have seen this kind of a problem before. We don't like having the I in the bottom because it's a square root. But we still have an I in the bottom here, but we're going to have to get the I out of there in a different way. When you have a complex number, not just an imaginary number, but an imaginary number and a real number being added or subtracted, the way you're going to get rid of that imaginary number is by multiplying the conjugate. A conjugate is the same exact expression, but with an opposite sign here in the middle instead. But we just got to remember whatever we do to the bottom, we also have to do to the top. Now, I gave you guys a shortcut for this, and I would highly encourage you to use it. However, you can do the box method. The shortcut for this is you take the A and you take the B, you square them and add them. So 4 squared plus 7 squared is 16 plus 49, which is 65. So the bottom's going to be 65. That is much faster than the box method for these ones. So when you're multiplying conjugates, this is the shortcut I would recommend using. On the top, we just need to distribute. Oops. You do want to see if you can reduce. It looks like 3 goes into both of these, but 3 does not go in the bottom, so I can't reduce. But you should always check to see if you can reduce anything out of all 3 of the numbers. But in this case, we can't, so we'll just leave it like that. This is a similar problem, but the top is a little bit more complicated to work with because it's not just a number this time on the top. It's also a complex number like the bottom. So we still want to get rid of that complex number on the bottom, so we're going to multiply by the conjugate again, just like we did on the last problem. I'm still going to use the shortcut for the denominator. So 8 squared plus 8 squared, 64 plus 64 is 128. So my denominator is going to be 128. So we're just using the shortcut here. Okay, but for the top, we can't use the shortcut because this is not a conjugate pair. So for this, we're going to have to actually just use the box method, which I guess I'll show off to the side over here. The I squared makes that a negative 16. Then we're going to combine the real numbers together. And then we're going to combine the imaginary numbers together. And so that would be my numerator. Now on this one we can reduce. Yeah, I think all three of these can be divided by 8. So we should reduce if possible. So negative 24 divided by 8 is negative 3. 8 divided by 8 is 1, so that's just going to be I. And 128 divided by 8 is going to be 1 and 6, I believe, 16. And there's our final answer there. All right, we want to identify the domain of this function. It says identify the range. We're not going to do that, just the domain. So to identify the domain, you take the radicand, you make it greater than or equal to 0, and you solve for x. So the domain is x is greater than or equal to 3. And what this means is that x can be any number that's greater than or equal to 3. It can't be anything else, though. Let's take a look at 28. Same question. We take the radicand, make it greater than or equal to 0, and then we're going to solve. Minus 4 on both sides. Divide. Now, I divided by a negative number, and when that happens, you have to flip the arrow, so that's a little something to be watching out for there. Maybe put a star there so you don't forget. All right? Let's go ahead and take a look at number 30. We want to solve for x. So the first thing you want to do is get rid of any numbers that are outside of the square root, but there aren't any, so we could skip that step. The second step is to square both sides, because squares cancel out roots. The last step is to add 1 on both sides, and there's our answer. But there actually is one more step. We should really technically check our answer to make sure it's not extraneous. In other words, that it doesn't give us a bogus answer. So I'm going to plug 50 in for x. And it looks like we're good. All right? But you do got to check for those extraneous solutions. Let's take a look at another one here. We're going to square both sides on this, because once again, there's no numbers outside the roots. And on this one, the squares just completely cancel out, and I have this. Now, anytime I have a fraction, what I like to do to fix that is multiply everything by the denominator. Why do I do that? Well, because if you multiply this by the denominator, they cancel. and so we no longer have a fraction. But we have to multiply everything if we're going to do that. All right, the next thing we're going to do is we're going to solve for n here. So I would minus the n on both sides. That leaves us 0 on this side and a 5n on this side. I got 5n minus 60 equals 0. So we'll add 60. And divide by 5. You're getting 12. Once again, we want to plug it in to make sure that our answer is good. So this is 36. 36 minus 30 is 6. Over here, 12 divided by 2 is 6. And so, since square root of 6 is a real number, and both sides match, then we have a good answer, and therefore 12 is the correct answer. All right, last topic we'll talk about today is graphing. All right, so when it comes to graphing, we have to think of our transformations that we've learned. So the h and the k make up your starting point. You have to remember that the h is going to be the opposite of whatever is here. Also, this number and this number combine to tell us the direction. And I gave you guys a little chart to help you with that, but I'll put it here as well. If both a and b are positive, then the graph goes that way. If a is negative and b is positive, then it goes that way. If a is positive and b is negative, it goes that way. And if they're both negative, it goes that way. And the starting point that we talked about is this end point that's away from the arrow. All right, so on this one, notice that there's no number underneath the square root with the x being subtracted or added, so that means that my h is 0. And the number outside is 3. So that's going to be my starting point. Next, I'm going to look at the b value. The b value is the number in front of the x, which is a 1. And that's a positive. Then I look at the a value, which is the number in front of the square root. That's a negative. Since my a is positive and my b is negative, we're going to be using that shape. And there's my graph. Do one more like that, and that'll end us for the day. In this problem, we don't have an h, so you can assume that it's 0. And we also don't have a k, so we can assume that that is 0. So my starting point is 0, 0. Since my b is negative and my a is negative, my shape is going to look like that. So starting at 0, 0, and using this shape here, that would be my graph. And that'll do it. So hopefully that was helpful, and we'll see you guys in class for your test. Have a good one.